Hello, you beautiful people. Today I'm going to talk about second learning methodology that I found it very interesting, and that is called project-based learning or PBL. Traditionally, like even I should say conventionally, in a conventional education system, it's so theoretical. It means like we go to schools, we get a bunch of theory, and then we try to practice. Still, even practicing is theoretical. It means, for example, you learn trigonometry in theoretical manners, and then you go and then practice, and then you're really good in trigonometry. But when I'm saying you're good, it means solve those questions, but you're not good at all to use it for the real life. If I ask you, okay, where you can use this, are you able to use this trigonometry to improve my home aircon health and condition? Do you know how you can use trigonometry in radio or TV or satellite or these kind of things? You have no idea about it because the foundation is theoretical. Expectation at the end of the semester also is theoretical again because you go to the same exam, memorizing and applying those skills, and then you're going to get your good mark. But in this approach, project-based learning, goal is different. There are maybe few schools in the world that they also give some projects to students within maybe one project for the whole semester, maybe two. But there are really few schools. Project-based learning is not about giving extra projects to students. No, it's not like that. It's about forget about the theoretical way, redefine and redesign the whole curriculum just by using projects. So that's a very important difference. So it's not like if your child is school, they give them projects, call it PBL. No, it's not like that. It's about curriculum itself. How it's going to work? It's very simple. Curriculum designer, first of all, they must have practical experience. So I can't be just a person good in mathematics or degree in math or PhD and come on and create a curriculum. No, I must be able that I'm using trigonometry, algebra, and all those kind of things in real life, or I do have that kind of awareness. So that's why typically these kind of curriculum designers, they need engagement with industry people to come and then give them some ideas. For example, if I'm a person in Google manager or Google engineer, I know where and how you want to use trigonometry in the search engine. If I'm coming from the Instagram, I know how to use, for example, that concepts into image processing and other algorithms. So what we do is this. We create multiple projects, small projects, based on some criteria design that we have. For example, we want children to learn this topic and that topic in biology, chemistry, philosophy, history, science, and mathematics. We define real life projects. For example, one project can be, hey, students, create a kind of drone that can fly and then use it as transportation because in future food delivery is going to be based on drone. So what are you going to do? You make a simple drone to just find some items, use magnet, and then bring it and then lose it somewhere else. So a small project, but has the resemblance of the real world. Or another kind of project is we want to have a research to figure out how to avoid little children to avoid to not get flu. What are the kind of things that they have to do, washing their hands or their hygiene or the food? So that's the kind of research in medicine, for example. So there are a lot of kind of topics like that. But what's going to happen? First step, team should start to do critical thinking, start to come up with the solutions and different ideas, brainstorming. And then number two, when they have their own solutions, they have to start collaboration. Teamwork is very important. They have to divide tasks between themselves. And finally, when they have the solutions, they have to come and present it, communicate it with other teams and with teachers and trainers and all the kind of people engaging that approach. So they keep doing this. And something very important is based on the projects they select, which we assign to them, for each project, they have to learn different things. For example, for that drone, they have to learn physics and trigonometry and some algebra. So then they will do self-study in the flipped class model, maybe the one that I talked about in the previous episode, or trainers, they teach them that topic. They go through it immediately. They utilize it in the projects. So we are following the standard curriculum somehow, but it's redesign in the way that they have to build something. And in this way, imagine after 12 years of school system, they are so ready to solve real world problems, or even at the age of 14, 15, and 16, they can do that. It's a very interesting approach. I really wish I had such a kind of privilege to do that. But in this approach, focus is on applying the knowledge to solve real life problems. But unfortunately, in the common approach, the conventional model is not like that. You have to go to university. Even if you finish your degree, you have to find a job. And in a few years, then you know why you learn. And then you know that many things that you learn, you don't need it actually. Just they're good to have the knowledge of it. But in this approach, project-based learning, critical thinking, collaboration, and communication, three important skills, and will be available for all the students. So again, remember that. This approach, it's not about giving some projects. No, it's about teaching by projects. And it's very different than sitting and listening. It's very collaborative. And something very important I'm going to add to end this topic is historically, the critics for this approach was it's difficult for a school to do that kind of things. There are a lot of materials and this and that. Maybe, but now, thanks to the digital world, we can define almost multiple projects, engage with computers, and also social engagement, which is cheaper, faster, easier, and relevant to the future of the economy. And they can use computers, simulators, and softwares, data analyses, and robotics, and medicines, and a lot of other things that children can enjoy from the machine that they're getting used to it, and their life is dependent on the computer, and they have to understand how to utilize it and use the knowledge into the real life. This was project-based learning, PBL.